Okay, so yesterday we focused on doing a proportion test for one side. Now we're going to look at two-sided tests. The p-value in a one-sided test is the area in one tail of the standard normal distribution. This tail specified by h sub a. In a two-sided test, the alternative hypothesis has the form p is not equal to p sub 0. So the p-value for this test is the probability of getting a sample proportion as far as or farther from p sub 0 in either direction than the observed value of p hat. So basically we're finding the area at both ends of the tails. As a result, you have to find the area in both tails of a standard normal distribution to get the p-value. The result of a significance test is basically a decision to reject h sub 0 or fail to reject h sub 0. When we reject h sub 0, we're left wondering what the actual proportion might be. A confidence interval might shed some light on this issue. Taeyeon found that 90 out of an SRS of 150 students said that they had never smoked a cigarette. The number of successes and the number of failures in the sample are 90 and 60 respectively. So we can proceed with calculations. So we can find a 95% confidence interval to be 0.522 to 0.678. So this tells us that we're 95% confident that the interval captures the true proportion of students at his high school who would say they have never smoked a cigarette. So there's a complete link between confidence intervals and two-sided tests. The 95% confidence interval gives an approximate range of p sub 0s that would not be rejected by a two-sided test at the alpha 0.05 significance level. So a two-sided test at a significance level of alpha and a confidence level percent gives similar information about the population parameter. So basically what we're saying there is that the confidence interval and this significance test is going to give you the same information. The confidence interval, I hope you see, gives you just a little bit more clarification. It tells you a little bit more about the information you're given. So type 2 error and the power of a test. A significance test makes a type 2 error when it fails to reject the null hypothesis when it's really false. There are many values of the parameter that make the alternative hypothesis true, so we concentrate on one value. The probability of making a type 2 error depends on several factors, including the actual value of the parameter, a high probability of type 2 error for a specific alternative parameter value means that the test is not sensitive enough to usually detect that alternative. The power of a test against a specific alternative is the probability that the test will reject h sub 0 at a chosen significant level alpha when the specified alternative value of the parameter is true. So the potato chip producer wonders whether the significance test h sub 0, p equals 0.8, versus the alternative hypothesis, p is greater than 0.08, based on a random sample of 500 potatoes, has enough power to detect a shipment with, say, 11% blemished potatoes. In this case, a particular type 2 error is to fail to reject our hypothesis when p is 0.11. So if our p was actually 11%, we should reject h sub 0. If we don't, then we've made a type 2 error. So the sampling distribution of p hat, if h sub 0 is true, is shown in this normal curve. If h sub 0 is true, a decision to reject h sub 0 based on the data would be a type 1 error. So right here, our alpha, the probability of a type 1 error, is 0.05. So what if P is equal to 0.11? If H sub 0 is false, a decision to fail to reject H sub 0 based on the data is a type 2 error. Sampling distributions of P hat, if H sub 0 is false and P is equal to 0.11 is true, gives us this new normal distribution. So the probability of a type 2 error is this unshaded region, 1 minus 0.7517, 0.2483. This right here, 0.7517, is called the power of the test to detect that P is equal to 0.11. Since we reject H sub 0 at alpha equals 0.05, if our sample proportion yields a greater than 0.0999, we'd correctly reject the shipment about 75% of the time. The significance level of a test is the probability of reaching the wrong conclusion when the null hypothesis is true. The power of a test to detect a specific alternative is the probability of reaching the right conclusion when the alternative is true. We can just as easily describe the test by giving the probability of making the type 2 error, sometimes called beta. The power of a test against any alternative is 1 minus the probability of a type 2 error for that alternative, 1 minus beta. Okay, so I think that was a little confusing. I'm hoping you'll watch the example and that will hopefully clear it up. We'll also do another problem in class tomorrow.